Okay, so good afternoon. Welcome to this presentation, and my name is Pasquale from the University of Bari, and with Marco we are going to present this reproducibility analysis of recommender systems relying on visual features, traps, pitfalls, and countermeasure. This is a paper accepted at the reproducibility track. So it is acknowledged that reproducibility is a cornerstone for scientific progress, and we are witnessing to an ongoing reproducibility crisis in several research areas, including recommender systems. We know that a large amount of published research cannot be reproduced. Sometimes it also happens with our own papers when we receive reviews from reviewers for papers submitted to journal. After some months, we struggle to find the right data set we use for the experiment, the exact split for training and test. So a recent paper has been introduced these concepts of accountability in recommender systems. And the authors claim that ensuring reproducibility in recommender system research allows getting accountable recommender systems. They claim that there are some required stages that should be properly documented for getting accountability. The first is the dataset collection. We should report statistics about data and, of course, pre-processing operation performed on the data. The data splitting, we have to report the way in which we have obtained training and test split, for example, by providing the random seed for random procedure, or the recommendation algorithm. We have to report the source code, the hyperparameters used in the experiments, the candidate item filtering strategies, which is to report the list of items that the recommender should rank, and the evaluation, which metrics we have used, which cutoff, which normalization strategies have been adopted, and of course, the statistical testing, which test, on which data, which p-value, and so on. Unfortunately, it is not enough, since currently recommender involve side information in the recommendation process, side information including text, images, audio, and video. So the reproducibility becomes even more challenging, since we have to recreate in a precise way both the representation for users and items. And if we have used a complex pre-processing on this side information, we have to report along with the pre-trained models. Marco will show that in the experimental evaluation, even small pre-processing on images might have an impact on the accuracy of the recommender. The contribution of this paper is threefold. We have developed the RecSys, which is an extension of the RecSys recommendation framework built in our lab, which allows to process and include images as a side information in the recommendation process. We discussed the main traps and pitfalls we encountered when trying to reproduce the VBPR, the visual Bayesian personalized ranking from implicit feedback algorithm, which leverages the visual appearance of items extracted from product images. And we have defined a recommender system reproducibility checklist, which helps researchers to ensure reproducibility of experimental results. Let's start with the first contribution. So RecSys is based on the RecSys framework. It is a framework written in Python, which allows to implement a complete experimental pipeline, starting from the content representation till the evaluation of recommender system. It is made up of three main modules. We have the content analyzer, which deals with the representation of users and items. The content analyzer integrates several state-of-the-art libraries for processing mainly text, and it provides a wide variety of knowledge-aware representation based on techniques based on embeddings or knowledge graphs. The recommender implements techniques for both score prediction and top-end recommendation based on the use of regressors, classifiers, and network-based algorithms, while the evaluator implements a family of metrics for assessing the performance of recommender and two statistical tests. The main distinctive aspect of CLARES is the fully support to all the stages for a full accountability through the generation of specific YAML file. Indeed, each module produces some YAML files that allows to take into account all the parameters adopted in the framework. For example, these are some excerpts of these files. In the content analyzer, in this case, we can see that items are represented using the description, and the description is represented using a pre-trained model taken from Gensim library. And as processing, for processing the text, it has been used the NLTK tool with several operations performed. Similarly, for the recommender, in this case, we have the necessary details to obtain the same training test split with the random seed to obtain the same random procedure. And in this case, the recommender is based on a support vector classifier trained with the description and tags using the word-to-vec representation. And finally, the evaluator. In this case, we have the list of metrics adopted in the evaluation, precision at 10, and there are some parameters. For example, 3 is the threshold for deeming an item as relevant. And then we have other parameters and the results. CLARES can see is an extension of CLARES and allows to include images as a side information recommendation process. So to this purpose, we have extended the content analyzer by implementing image preprocessing functionalities to filter out irrelevant elements. In particular, we have implemented several preprocessors for dimensionality reduction and for augmenting images based on torch vision. This allows to resize, to center image, to crop, to flip them horizontally, vertically, and so on. We have integrated feature extraction techniques, in particular low-level techniques which implement some state-of-the-art methods, and high-level techniques which leverage some pre-trained embeddings from pre-trained models to represent images as embeddings. And finally, we have implemented post-processing techniques for example, for dimensionality reduction. For the recommender, we have extended the recommender module with the implementation of VBPR, the Visual Bayesian Personalized Ranking for Implicit Feedback algorithm, which is able to exploit visual features extracted from images to generate better recommendation. We decided to reproduce exactly this algorithm since VBPR is a highly cited, the paper is a lot of citations. It is grounded on the famous BPPR, Bayesian Personalized Ranking methods, which is widely adopted in the recommender system literature. And from a preliminary analysis, it seems one of the best reproducible algorithms since there is the availability of the source code and also of the data set. In a nutshell, VBPR is trained similarly to the Bayesian Personalized Ranking with triples, which reports for each user a set of items which are preferred over other items. The optimization strategy works on a preference predictor, which is the classical predictor used in matrix factorization with additional signals coming from visual factors to deal with the call start. In this case, the item factors are they're projected into a lower dimensionality space, and we obtain the predictor in the last row, which is the one used in the BPR optimization strategy. Now I leave the stage to Marco for the experimental part in which he will describe the main traps and pitfalls we encounter in trying to reproduce VBPR.
Okay, so what we conduct are 3 different experiments. So we tried to evaluate what we implemented and also the replicability of the original results of the VBPR paper. So the starting point was to try to analyze which kind of data sets we need to use. And what we have done was to go into the original paper proposed by Macaulay and try to understand what are the data sets used in the paper. So the authors report that they use Amazon women, men, phones, and Tradici. And first of all, we tried to go on Google and search for the data sets, but we were not able to find exactly the same version reported by the authors about these 4 datasets. In particular, about the Amazon datasets, we were not able to map this we can say name of datasets directly with those available online. We were able to do this only for the Tradici dataset, but also for the Tradici dataset, the version that we found online was not so, it was not exactly the same to the one reported by the authors, because we have a slight difference in the number of users, items, and feedbacks. This is due to the fact that into the dataset that we found, the duplicates were removed from the dataset. So we decided to use the Tradici dataset that we found, and we, first of all, tried to reproduce exactly the same original results of the paper, but as you can imagine, if we start from a different dataset, we will never able to find exactly the same results. Anyway, we tried to replicate the same protocol, but we tried, first of all, to reuse the code released by the authors. We went on the web page released into the paper, but it was protected by a password request for reusing the code. We make our request, but we never received any kind of answer by the authors. So we decided to use our implementation of the VPR, the one that we put into Claire's. Similar situation happens when we tried to reuse the splitting of the dataset. As I said before, it was not provided, so it was not able to, we were not able to reproduce exactly in the same split. And also for image preprocessing strategy adopted by the paper, we were not able to exactly reproduce the same identical pipeline. Anyway, we were able to include and import the vector features released by the author into ClayRS. So we were, we can say, with some difficulties, we were able to reuse some of this information. Another problem was about our implementation with PyTorch. So as you know, it produce results on different machines that could be slightly different, and for this reason we decide also to run our framework, our experiments over 2 different systems, over 2 different machines, in order to be sure that our implementation was robust enough. And we also decided to compare our implementation with the one provided by the Cornac framework, which is we can say, standard and well-known robust framework for recommender systems. And by running the experiment, changing the epochs, we saw that the results that we obtain are quite robust, and we doesn't observe any kind of significant differences into the results. So we were sure that what we obtain are at least the same that you can obtain with another framework famous into the literature. As a second experiment, what we have done is to try to understand what is the impact of preprocessing operations over the final results that you can obtain by using the algorithm. And in particular, we tried the standard pipeline of the BVLC reference CAFENet model, which is the standard reported by user and reported by the original authors. And then we also tried to apply a simple sentence crop operation. What we observed, as expected, is that by applying just this simple operation of preprocessing, we obtained completely different results, and these results are statistically different. So this means that it's really important to ensure the full reproducibility of results, to report all the preprocessing operation, hyperparameters, and so on into your paper. Final, as a third experiment, what we have tried to do is to understand what is the impact of changing the strategy of representation of the item feature, in this particular case, the image feature. So we changed the pre-trained model used for encoding our items in order to see what are the differences in results. And again, as expected, we obtained completely different results. Again, the differences were statistically different. So again, it's it's really important to provide exactly the model that you use for encoding the items and the features of the item. So as a take-home message, what we have learned from this experience is that it's important to report and distribute every parameters, all the configuration, everything about your algorithm and about your model. So what we decided to do is to release for the community this checklist. We inspired from the one already available for machine learning models. And for this reason, we decided to, you can say, modify it a bit in order to make it good enough for recommender systems. And then we follow exactly this checklist that we are proposing to you for releasing our results. And you can find them directly over our GitHub page. And as you can see by this screenshot, you can find all the details that someone else could need for reproduce completely the results. So, as a recap, and as a future work, what we have just introduced to you is Claire's can see framework. It allows you to reproduce, to create your algorithm and to release it to the community with a completely reproducible pipeline. As a future work, we are working both on text and images and extend CLAIRE to include also side information of other kind of items like audio and videos. Thank you. I'm here if there are some questions.
Yeah, we have some time for questions. I'll ask one to get started. So how much of kind of what you're looking at really do you think depends on it being visual inputs versus kind of anything where you have the kind of models and very complex, sub-models, processing features? Do you think like a lot of the same challenges likely apply?
Yes, we have worked mostly with text in these years, but now that we are approaching also the working with images, and we are, as you see in the future work, also with other kind of multimedia information, audio, videos, I know that we should pay more and more attention since, as Marco has shown, even a very simple, small preprocessing and change operation might have a significant impact on results. So it was a very nice paper, VBPR, but we were absolutely upset with the lack of also operation and preprocessing operation on images. The authors have provided the embeddings related to the images, and we were able to include those attributes for performing experiments, but we do not know anything about the size of the images, the kind of preprocessing performed on that. So
yeah, just to kind of follow up on that, so you kind of think that with images, there's probably typically a lot more pre-processing that has to be done in order to make them useful versus if you're doing a lot of things with text before, people typically wouldn't do as many like kind of cleanup and data set changes to it. Okay, cool. Let's see. For the people in person, feel free to come up to the microphone. There is a couple online questions. This one's from Tommaso. It's sometimes there's not enough space in the article to be exhaustive about the reproducibility settings. Do you have suggestions to be, it says systematic but complete?
Yeah, I read. I think, of course, we cannot report all the details related to the preprocessing operation on the paper. Otherwise, maybe it's not good also to read this kind of papers. But I think the paper should report the most important protocol for experiments in order to give the flavor. But information, more specific information, such as the preprocessing operation, hyperparameters, could be included in the reproducibility checklist we made available. So I think it should be available a GitHub or a web page space in which all the necessary details, specific details, technical details could help to reproduce the result.
Cool. Tommaso has a follow-up question saying, could this reproducibility checklist become also a standard to decide about the acceptance of articles?
I hope so.
Okay, let's see. From Dimitro, how do you feel about more standardized approach rather than a convention? Fixing a shareable data set with DVC, all the model parameters with MLflow, etc.
Yeah, it is a kind of technique that is often used in machine learning experiments. We have also, we made this hypothesis when we were working on the framework. Yeah, it could be also a good choice to implement.
All right, one more question from online. How does the use of LLM approaches affect the reproducibility framework? So I'm wondering if people are using like, say ChatGPT or something and the version changes out underneath you.
Yeah, I think that right now we have included into the framework PyTorch. So for sure you can be able to load any kind of LLM and use it into the framework for as a part of a recommendation algorithm. And the framework is able to automatically collect all the hyperparameters that are also used when using a large language model and report it into the YAML file that could be later released. So I think that there is not so many changes that we have to do at the framework because it already supports this kind of technology right now.
Awesome. I think that's it in terms of questions. Let's thank our speakers again.
Thank you.